Hi, everybody. I hope you had a happy Thanksgiving. Today, we're going to do 3-6, which covers how to solve systems of equations using matrices with the calculator. Woo! So, you're going to need a calculator. There's plenty to go around, and it's super way better than doing this by hand. So let's get started. So a matrix is a rectangular array of numbers. You usually display the array within brackets. That's these things. The dimensions of a matrix are the numbers of rows and columns in the array. And so matrix A here has 2 rows, 1, 2, and 3 columns. 1, 2, 3. Columns are up and down, rows are side to side. So matrix A is a 1, 2 by 3 matrix. And you can write it as either matrix A or A 2 by 3. Each number in a matrix is a matrix element. You can identify the matrix element by its row and column numbers. In the matrix, little a is the element, and then 1, 2 means it's in the first row, second column. So first row, second column, 4 is your matrix element 1, 2. Okay, so it's always rows first, then columns. So you can represent a system of equations with a matrix. Each matrix row represents an equation, and the last matrix column shows the constants to the right of the equal sign. So it's x, y's constants, or x, y, z constant, or a, b, c, d, e constant. In this particular example, you might notice that the coefficient of that x is 1, and the coefficient of this y is 1. And the coefficient of this x is 3, and this y is 3. Coefficient, remember, is the number in front of a variable. So I'm going to write that right here. Coefficient is the number in front of the variable. And if there isn't a number, then it's a 1. If there isn't a variable, then it's a 0. It's like the difference between a banana and not even mentioning bananas because you don't have a banana. Okay, so you put the x coefficients in the first column and the y coefficients in the second column. And then sometimes there'll be a line, sometimes there won't. Like when you're doing these in the calculator, there won't be a line. And then the other side of the equal sign. So that's 7, -8 from up here is down here. So let's get to work. What is element A23 in the matrix A? Well, it's in row 2, column 3. Row 2, column 3 is, here's the second row, and the 1, 2, third column. So 8. 8 is matrix element A23. Now we're going to get a little funny because we're going to start putting these elements in matrices. Now, in order to do that, your x's and your y's have to be on the same side of the equal sign. So this equation here doesn't work. We need to subtract 6y from both sides. So now we get x minus 6y equals -1. So we have this equation, which we'll put in the first row, and there's a 2 we have 1y and a 9. So 2, 1, 9. And then our second equation is right here. And that would be 1x minus 6y's and negative 1. So this is a negative 6, not a minus 6. And that's all there is to it if we're just making a matrix from a system of equations. It's just asking for those 6 numbers in rectangular fashion. Let's try this next one. It's a little bit trickier, but it's not horrible. So we have the first equation has 1x minus 3y plus 1z. So we'll make our bracket. We're going to have 3 rows this time because we have 3 equations. So that first row, we're going to have a 1 for the x, a negative 3 for the y, and a 1 for the z, and a 6. Okay, hopefully everybody just got that. The second equation, we have 1x, and 3 z's, and a 12. How many y's do we have? Why, we don't have any. We have none. We have 0 y's. That was the bell on the video. Bells still ring when nobody else is here. The last equation, we have 5 x's, 1 y. How many z's? Oh, we have 0 z's. And our constant is 1. And that's all there is. You just put the coefficients into the equation and then the constants at the very end. 1 row per equation. So now, how to use your calculator to solve a system of equations. First, you enter the matrix into the calculator. So here's the handy dandy calc. And you turn it on. And then you hit the second button. And then this button here says matrix in blue right there. And these are the matrices that are entered into my calculator. So let's take a peek at the matrix we just did, just to enter it. Now, here's the matrix we just did. Well, I did it a couple times. And it's a 1, 2, 3 row by 1, 2, 3, 4 columns. So we're going to go over to edit, because we're going to edit the matrices that I already have, and hit enter. And now I already have a 3 by 4 in there, so I can just hit enter, enter. If you have anything in there, put the 3 in, hit enter, enter 4 again. Now, if you enter those numbers, 1, enter, negative 3, enter, 1, enter, and then the last row, column pops up, 6, enter, 1, enter, 0, enter, I'm going right across, 3, enter, 12, enter. And then our last row from the last slide would be 5, enter, 1, enter, 0, enter, 1, enter. Now we're all done, so we can just go second, quit. If you go back into matrix, so go second, matrix, and we just did A, sorry about the bells, we just did A, so we can hit enter and it'll say matrix A, and you just show, you hit enter again, and there is our matrix. That our first column is 1, 1, 5. Second column is negative 3, 0, 1. Third column is 1, 3, 0. And fourth column is 6, 12, 1. If I've lost you and you're saying, where did you get these numbers, Mrs. Lons? It's right here. I put this matrix right into the calculator. See how similar they look? Very, very similar. So, if I wanted to solve this systems of equations following these steps, we did step 1. That's what we just did. Step 2, we're going to apply the reduced row echelon form function to the matrix. You do not need to know that that's called the reduced row echelon form or how to do it on paper, because we are just going to go into our calculator and say, okay, we're going to go second matrix. Now we're going to scroll over. See how is it names? We're going to scroll over to math. And then we're going to hit the down button. And I believe it's letter B. Yes, it's letter B that we want. See how it has 2 R's? It's REF. Do not do REF because that won't give you the right answer. You want REF. Or RREF if you want to not sound like a barky dog. So you REF, and then you say, well, what do I want to do reduced row echelon form on? And the answer is you want to do that on matrix A. So second matrix, and this time again, we just want to say matrix A, so you hit enter, so that it says REF matrix A. Then hit enter. Whew! That looks crazy ugly, but it's not, because you see the first 3 columns here, how we have the ones going in a diagonal line downward? That means we did this right. The answers are yucky looking. And in Math Excel, more often than not, they'll ask you for a fraction. So you're going to want to hit Math, this button right here, Math. And then that very first number 1 says fraction. You say answer, turn it into a fraction, and there you go. That is our answer. The answer is a little bit ugly, but what it's saying is for this system of equation, let's move it up here, the answer is going to be an ordered triple. And let me see if I can make that show up a little better. Good. The answer for the x is 15 over 47, because the top one is x, because the 1 is in the x column. The 1 is in the y column, so your answer is negative 28 over 47. And the 1 in the z column is 183 over 47. That would have been an extremely yucky problem to do by hand. So let's work on some practice problems. So it says solve this system of equations. Step 1, write down the coefficient matrix and enter it into the calculator. There will be how many rows and how many columns? Well, we have 1, 2, 3 equations, so we have 3 rows, and we have 1, 2, 3 variables plus the constant, so we will have 4 columns. So this will be a 3 by 4 matrix. Okay, so now we're going to enter that into our calculator. I like to write down the matrix first so I can check it, so that I can keep myself from making an error that's fatal. So I have for the first column, first row, I have 2 A's, 3 B's, minus 1 C's, and a constant of 1, because that's minus 1 C. Then I have negative 4 A's, 9 B's, 2 C's, and my constant is 8. For the final row, I have negative 2 A's plus 0 B's plus 2 C's, and my constant is 3. So right now, I need my matrix A to equal that, and it's going to be a 3 by 4. So let's get started. Second matrix. I'm going to scooch over to edit. Scooch, scooch. Enter a 3 by 4. And our matrix is going to be 2, enter 3, enter negative 1, enter 1. And that was our first row. Negative 4, 9, 2, 8. That's our second row. Negative 2, 0, 2, 3. It's our final row. Second, quit. Then we go back into matrix. We scroll over to math. And then scooch to the bottom, well, whoops, to be ref. And then we're refing second matrix, matrix A, close parenthesis, enter. Oh no, we got decimals. No biggie, math, fraction, enter. Look at that. So our solution to this set of systems of equations is 1/2, 2/3, 2. And that's all you have to do. You might want to know that you can use this to complete any missing homework in 3-5 or any of your solutions of equations problems in this section. We didn't show it to you at the beginning because we didn't want you to not know how to do it. Okay, so here's a system of equations. We've got 2 rows, and it'll be 1, 2, 3 columns. Our matrix will be 1, 3, 22, 2, negative 1, 2. So we put that in our calculator. Second quit. Well, okay, no we don't. Second matrix. I like to just keep it at A unless I'm multiplying several matrices together, which we aren't going to do right now. So, edit. This is a 2 by 3 matrix, and it's 1, 3, 22, 2, negative 1, 2. Second quit. Second matrix, math. Scroll, 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 scroll. Ref. Second matrix, A. Enter. Oh, look at that. That was a nice, happy one that our answer is 4, 6. Way quicker. One last one we need to get taken care of. This is going to be a 3 row because we have 1, 2, 3 rows of equations and 1, 2, 3, 4 columns. So it's going to be 2, 3, 1, 13, 5, negative 2, negative 4, 7, 4, 5, 3, 25. So let's put that in the matrix. For number A, And we change this back to a 3 by 4. Okay, it focused back up for us. So 2, 3, 1, 13. Then 5, -2, -4, 7. Then 4, 5, 3, 25. Second, quit. Second matrix, scooch over to math, and then down, down, down to ref. Second matrix, A, and we get, oh, that's a nice pretty one too. We know we did it right because we've got these diagonal ones. And it's x is 3, y is 2, z is 1. That's all there is to it.